So far we've learned about quadratic functions, which are examples of polynomials, but today we're going to talk about more general polynomials, and eventually we're going to learn how to graph them. So the most general kind of polynomial looks like this, where we have a sub n times x to the n. These powers of x range from 1 up to n, and n is the highest power of x appearing in the expression of p. So p is just a sum, so you're adding up a bunch of powers of x, like here we have x to the n, x to the n minus 1, and all the powers go down until you get x to the first. And each power of x is multiplied by some number. So an example of polynomial would be p of x equals 5x to the fourth plus 16x minus 4. So here n is 4, that's the highest power of x appearing. And 5 is equal to a sub n from over here. Now x cubed and x squared don't appear here, so those coefficients would both be 0. 16 is the coefficient attached to x, minus 4 is the coefficient attached to x to the 0 power, which is just 1. So here, remember that coefficients are the numbers that are in front of the powers of x. Now, the highest power of x appearing is important, and this term, this called the leading term, will be important later when we try to graph these functions. So you should always keep in mind the highest power of x appearing in this expression called the leading term. So here the leading term is 5x to the fourth. Here it would be negative 2x cubed. And here you would have to multiply everything out to figure out what the leading term is. Okay, so our goal eventually is to be able to graph a general polynomial. And the things we want to be able to graph are the same kinds of things we could graph for quadratic functions. We want to graph the x and y intercepts. So here we see the x-intercepts and the y-intercept right there. This is the graph of r of x. Eventually we'll be able to do this, but we're going to do it piece by piece. So we know how to graph x and y-intercepts. You find them the same way. You set r of x equal to 0 to find the x-intercepts. And to find the y-intercepts, you plug in 0. So that's the same. Actually, this is true for any function. This is how you find the x and y-intercepts. But how do we figure out what goes on over here on the outsides, and how do we figure out what happens in the middle here? We'll talk about that later. For now, all you need to know is that polynomials always have domain all real numbers, minus infinity to infinity, and the graphs are always smooth. There won't be any corners or any points.